Hello everyone, today I'll be going through how to link ACP with the ACCS RTM solver. The first step is to define your engineering data. So let's head into engineering data here and double click. Here we can delete the structural still as we won't be using this. And then we can head into engineering data sources. From here we should click Cure Simulation and add the RTM fabric as well as the RTM resin with constant viscosity. After you've added these, we can head back to the main page of engineering data and we can see the materials are added below. In RTM fabric, the only unique material property to ACCS is permeability. And in RTM resin with constant viscosity, the only unique property is the constant viscosity. If you want more details on these properties, you can refer to the ACCS documentation manual. Now we can close this and drag and drop our ACP module. Here we can drag and drop the external model as well as the engineering data, and we can update. When mechanical is open, you'll be greeted with this screen here. The first thing to do is to define the cross section. To do this, we insert a cross section, and in this case we want a circular cross section. This will be for the pipe element here, the line body. We'll set the radius of the cross section to 10 millimeters. After this, we will need to suppress the material assignment of the external model and assign the cross section to the line body here like so. After this, we will assign materials for the line body and we'll set this as the fabric we picked earlier, and we'll also set the material of the surface body here. We'll then define the thickness of the surface, which will be set to 3 millimeters. After all this is set, we can close it like so and update our model. After the model has updated, we'll double click Setup to start our ACP setup. When inside of the ACP menu, the first thing to do is to set the units. And do so here, and here we'll be using millimeters. After this, we'll define our fabric. So here we can create a fabric called fabric 2. And we'll use our RTM fabric as the material, and we'll have a thickness of 3 millimeters. Delete this one. After we've created our fabric, we can create our orientated selection set. Here for the element set, we'll define it as all of the elements, and we'll set the direction to the X direction. We'll set the rosette as the global rosette, and we'll set the rotation angle to be 0. After this, we can create our modeling group, and we'll create our plies. In this case, we'll select the orientated selection set as the one we created earlier, material as fabric 2, and we'll have one layer of 0 degree, and we'll insert another ply, which will have the same settings, apart from the fact that this ply will have an angle of 45 degrees. And finally, we'll create one last ply, again with an angle of 0 degrees. After all of this is done, we can close ACP here and drag and drop our RTM system. After this, we can link our ACP by dragging and dropping setup onto the model. In this case, we'll transfer the shell composite data and we'll update. After the model is updated, double click and we can enter mechanical for the RTM simulation. Once you're in mechanical, you'll be greeted with this screen here, and the first step will be to create a node merge. To do this, just right click on Mesh Edit, press Insert, and then press Node Merge. I've already created one here, and you can see that it's between the two bodies in the model. This is important as if the two models are not linked via a node, the RTM simulation will not run properly as the flow travels through the nodes. After this, you want to create your inlet and outlet as normal. For the inlet, we'll set it to 1000 megapascals, and we will assign the edge of the pipe here. For the outlet, we'll assign the opposite edge to the pipe. And then after this, we can create our results. So we want to see the fill, and we want to see the infusion time. And then we can solve. Oh, but before you do so, you need to make sure to set your resin, of course. So here we'll set the resin to the RTM resin with constant viscosity. And now we can solve. Once the model is solved, we can now view our results. So if we look at the fill results, we can see the end time of the simulation in the top left here, as well as the fill at the end of the simulation. So you can see the model is fully filled. If we want to look at the progression of fill over time, we can press play on the animation here. And if you want to view the fill at certain time points, just click and right click and press retrieve this result, and you can see it like so. You can also see an infusion time, the time it took for each area of the model to be filled in. That's it for today's tutorial. Thank you for watching.